In today's lesson, we're going to look at the molar mass of compounds. Molar mass is expressed as capital M. And to find the molar mass of the compound, simply add the masses of each element in the compound in its proper quantity. So, for example, I'm going to look at three compounds. The first one is NaCl, or sodium chloride. I'm going to try to find the molar mass of that. Looking at my periodic table, I can see that sodium is 23 grams per mole, and chlorine is 35.5. So we have 35.5 grams. Now, at the atomic level, there are 23 AMUs and 35.5 AMUs, but as like a 1 mole quantities, we just convert the AMUs directly to grams. So, pretty easy. 23 grams plus 35.5 grams gives me 58.5 grams per every mole of sodium chloride. Let's try magnesium bromide. So magnesium, looking at my periodic table, is 24 grams. And I have bromine, which is 80 grams. But since I have two bromines, well, I have to double the amount of mass for each bromine. So in this case, it's 80 grams multiplied by 2. So 24 plus 80 times 2. 80 times 2 is 160 plus 24. I get a grand total of 184 grams for every mole of magnesium bromide. Now let's take a look at calcium phosphate. So now we have calcium 3PO4 2. So we have to take into account all of these atoms and have each individual one accounted for. So I have calcium, which is 40 grams per mole. So I have 3 of them. 3 times 40 grams. And I have 2 phosphoruses, 2. So 2 and phosphorus is going to be 31 grams. Plus, I have 2 times 4, which is 8 oxygens. And they're 16 grams per mole each. So I either do it the long way or just plug it into my trusty calculator. 3 times 40 plus 2 times 31 plus 8 times 16 is going to be a grand total of 310 grams per mole. And the bigger the compound, obviously the bigger the molar mass. Like some molar masses can be in the thousands or millions or even billions if you can even consider molecules as large as DNA. So that's actually quite large. But we can always find the molar mass by just counting the number of atoms and figuring out the molar mass for each one of those atoms and how many there are. So these examples are found with 1 mole of compound. If we vary the amounts of moles of mass, what can we do? Well, we can use this kind of very basic equation. I've already shown you one triangle, and this leads to our second triangle. So we have our second triangle, number of moles, and number of moles times the molar mass, times molar mass will give us the mass. So this is my mass, this is my molar mass, and this is N is, of course, number of moles. So this allows us to convert between mass and molar mass. And even incorporating our other triangle with Avogadro's number, we even incorporate the number of particles. So, for example, I have a flask that contains 0.75 moles of carbon dioxide. I want to know what the mass of carbon dioxide is in the flask. Because if I actually put it on a scale, it might not measure it directly because carbon dioxide is a gas. But the mass doesn't change. So I have N equal to 0.75 moles. My molar mass is going to be equal to carbon, which is 12 grams, plus 2 times 16 grams for oxygen, which gives us 44 grams per mole. My mass is going to be number of moles times the molar mass, let's move this down, which is going to equal 0.75 moles times 44 grams per mole, equals 33 grams in the flask. Now let's try another example. How many moles are there in a 324.7 gram sample of iron chloride? So now I'm going to go backwards. I don't know the number of moles, but I do know the molar mass, or at least I can figure it out via my periodic table. So I have iron, which is 56 grams per mole, and I have 3 times chlorine, which is 35.5 grams per mole. That's going to give me a grand total of 56 plus 162.5. And my little m, my mass, I have 324.7 grams. So figure out the number of moles. It's going to be the mass over the molar mass. I have here 5 grams per mole. So that's going to roughly be 324. I'm going to get 1.988 so far. It's going to be 2 moles if I use significant digits. All right, so there I just did one where I didn't know the moles, another one where I didn't know the mass, or I didn't know the mass of the compound. Now I can expand this further using number of particles and Avogadro's constant. So for this question, I want to know what the mass of 5.6 times 10 to the 24 molecules of NaCl is. Well, I'm given 2 things. I'm given the number of particles, so in this case, number of molecules. Also given the formula from which I can figure out the molar mass. What I'm also given, but I don't really know it, is Avogadro's number. So I can actually figure out the number of moles with my number of molecules and Avogadro's number. So number of mole is going to be equal to the number of particles, or in this case molecules, over Avogadro's number, 5.67 times 10 to the 24 over 6.02 times 10 to the 23. So these all cancel out. I'm left with 5.6 times 10 over 6.02. So that's 56.7 divided by 6.02 gives me 9.4 moles of NaCl. Now I want to know how much that weighs. What's the mass of that? So I use my other triangle. The mass is going to be equal to number of moles times molar mass, 9.4 moles times 58.5 grams per mole. Figured that out in a question before. And that gives us a grand total of 551 grams of NaCl. So that way we can incorporate both number of moles, Avogadro's constant, and now we can also incorporate molar mass. And this gives us relationships and quantities that we're used to and we can deal with quite easily.